The air over the Coral Sea changed on March 19, 2026, and anyone watching the satellite feeds knew immediately that something was different this time. What began as a disturbance just days earlier had transformed into one of the most powerful tropical cyclones ever recorded approaching the Australian coast. Winds screaming at 195 miles per hour, a wall of clouds so vast it could swallow entire states. And it was moving, deliberately, almost patiently, straight toward land. This is the story of Cyclone Narelle, a storm that didn't just arrive, it announced itself like a geological event. One that has already changed lives, redrawn emergency maps, and left scientists watching a system that refuses to die on schedule. What you're about to hear is not speculation. Every number, every location, every official response documented here comes from the Bureau of Meteorology, NASA Worldview satellite data, government evacuation records, and on-the-ground reporting from ABC News Australia, Fox Weather, and USA Today. This is what actually happened, and it is not over. It started the way most catastrophes do, quietly, and then all at once. On March 17, 2026, a tropical system in the waters northeast of Australia received its first official classification, commencing at 4 in the afternoon, Australian Eastern Standard Time. By March 18th, it had already strengthened to a Category 3 cyclone tracking toward far north Queensland. Meteorologists noted it. Tracking stations activated. Emergency management offices in far north Queensland began their standard monitoring protocols. But Narelle didn't dissipate. Within roughly 24 hours of reaching Category 3, the system underwent what meteorologists call rapid intensification. The warm, deep waters of the Coral Sea, waters that act like fuel for tropical cyclones, fed Narelle's circulation with extraordinary efficiency. Environmental conditions, including low wind shear and high oceanic heat content, were, according to forecast models, optimal through the first 36 hours of development. That is the kind of language meteorologists use when a storm has everything it needs and nothing standing in its way. By March 18th into the 19th, Narelle had strengthened to Category 4. And then, within hours, it crossed the threshold that separates severe from catastrophic, Category 5. Peak winds of 195 miles per hour, 315 kilometers per hour, confirmed by NASA Worldview satellite imagery acquired on March 19th and corroborated by Fox Weather analysis. At those wind speeds, structures designed to survive cyclones begin to fail. Corrugated roofing becomes shrapnel. Trees don't bend, they snap at the base. The air itself becomes a weapon. NASA's VIIRS instrument aboard the NOAA A-21 satellite captured Narelle's true color imagery on that day, showing the storm's perfectly defined eye wall approaching the Queensland coast. The spiral bands stretched for hundreds of kilometers. The symmetry was almost beautiful, if you didn't know what it meant. But that's only part of the story. To understand what Narelle did next, you need to understand the geography it was targeting. Cape York Peninsula is the northernmost finger of Queensland, a remote, sparsely populated stretch of tropical wilderness that juts into the ocean between the Coral Sea to the east and the Gulf of Carpentaria to the west. It is not a place with reinforced coastal infrastructure. It is not a place with multiple evacuation highways. It is a place where small communities sit exposed to open water, where the soil absorbs rain until it cannot, and where flooding doesn't trickle. It surges. At approximately 7 in the morning on March 20th, 2026, tropical cyclone Narelle made its first landfall east of Cohen on the Cape York Peninsula. The system had weakened slightly from its Category 5 peak. Satellite data and crossing dynamics always exact some toll, but it still arrived as a severe Category 4 cyclone. Sustained winds near its center were recorded at approximately 120 miles per hour, or 195 kilometers per hour. Destructive gusts exceeding 250 kilometers per hour tore through the landscape. Communities in the impact zone included Cohen, Orukan, and Lockhart River. These are not large population centers, but they are real places with real families, and they bore the full weight of what a Category 4 system delivers at landfall. Structural damage reported across coastal areas, trees torn down, power lines collapsed, roads rendered impassable. Queensland authorities had already ordered school closures and evacuations. Rivers across the region had absorbed 400+ millimeters of rainfall in the preceding days, swelling to dangerous levels before the storm even arrived. The Bureau of Meteorology had issued rainfall forecasts of 100 to 250 millimeters over 24 hours across Queensland's affected zones. Forecasts that, based on ground-level reports, appear to have verified accurately. When you deposit that volume of water onto already saturated soil over a matter of hours, the result isn't simply flooding. It's the erasure of roads, the isolation of communities, the severing of the supply chains that keep remote areas functioning. And then Narelle didn't stop. It crossed the Cape York Peninsula, an overland journey that took more than 12 hours, and emerged on the other side into the Gulf of Carpentaria. That crossing was significant for one reason above all others. The Gulf of Carpentaria is warm. Its shallow, heat-retaining waters have long been understood as a re-intensification zone for tropical systems that manage to reach them. Narelle reached them weakened, but alive. What came next confirmed that this storm was not following the script. Yet what comes next could be even worse. The history of Australian tropical cyclones is not short of catastrophe. But to understand the fear that Narelle triggered among meteorologists and emergency managers, it helps to look backward to what storms of comparable scale and trajectory have done before. In March 1999, Cyclone Vance made landfall near Exmouth on the western Australian coast as a Category 5 system. It remains one of the most destructive cyclones in Australian history, causing tens of millions of Australian dollars in damage and leaving a trail of destruction across the Pilbara region's exposed coastline. Mining operations that form the economic backbone of that region were shut down entirely. The storm surge and wind damage reshaped the physical landscape of the coast. And there is an earlier Narelle, because this name has appeared in Australian cyclone history before. In January 2013, a tropical cyclone Narelle formed in the Indian Ocean northwest of Australia, reaching Category 4 intensity at its officially assessed peak. That system caused some insured losses, though its human toll was limited partly by its track and timing. The Bureau of Meteorology's official tropical cyclone archive documents it clearly. 2 different Narelles, both reaching major intensity, both threatening Australian coastlines separated by 13 years. That kind of historical echo doesn't go unnoticed in the meteorological community. When a storm shares a name and a threatening track with a predecessor, it forces a reckoning with a question that disaster planners rarely get to answer in advance. What happens if this one tracks differently? The 2013 Narelle stayed largely offshore during its peak. The 2026 Narelle did not. The communities that bore the first landfall, Cowan, Orukun, Lockhart River, are the kinds of places that don't appear prominently in national weather coverage during ordinary weeks. They are remote. Their residents are resilient by necessity. But resilience has physical limits, and those limits are defined by wind speeds, rainfall totals, and the structural integrity of buildings that were never designed to withstand a direct Category 4 strike. Emergency services recognize this. Northern Territory authorities went further than warnings. They acted. And now, scientists fear history may be repeating itself. The second chapter of Narelle's assault began on the night of March 21st into the early morning hours of March 22nd. After crossing the Cape York Peninsula and re-entering the Gulf of Carpentaria, Narelle made its second landfall on Australia's eastern Northern Territory coast, in the region between Birani and Numbulwar, crossing near Cape Shield at approximately 13.8 degrees south latitude. By this point, the system had weakened to a severe Category 3. Sustained winds near the center were recorded at approximately 130 kilometers per hour, with gusts reaching 185 kilometers per hour. Those numbers sound modest compared to the Category 5 peak. They are not modest. A Category 3 cyclone is still a major storm capable of destroying structures, generating dangerous storm surge, and producing life-threatening rainfall. Numbulwar's approximately 500 residents had not waited for landfall to find out for themselves. The Northern Territory government coordinated a full evacuation, an airlift operation that transported those residents to Darwin before the storm arrived. That decision, made under compressed timelines with limited infrastructure, represents an extraordinary logistical achievement. It also reflects how seriously authorities assessed the threat to that community. Rainfall forecasts for the Northern Territory called for up to 250 millimeters or more in 24 hours, with localized falls near Catherine potentially exceeding that figure. Coastal hazard warnings were issued for abnormally high tides across the peninsula and Gulf country districts. Storm surge and coastal inundation warnings covered the Gulf Coast. Warning zones issued by the Bureau of Meteorology stretched from Numbulwar to Port MacArthur, encompassing Borroloola, Numbulwar, Groot Eiland, and Barani. Watch zones extended further west to Ramingining, Bulman, and Ngukur. That is not a small warning footprint. That is a warning system covering a vast arc of tropical Australia's most vulnerable coastline. Severe weather alerts remained active across the top end as of March 22nd, with BOM extending warnings inland through the Catherine region toward Darwin's broader catchment area. Roads across the region were expected to close, isolating communities in ways that could persist for days or weeks depending on flooding severity. Heavy rescue and recovery operations were already being staged. As of the morning of March 22nd, no deaths had been reported. That fact is significant. It reflects the effectiveness of early warning systems, preemptive evacuations, and the institutional memory that Australian emergency management agencies have built across decades of cyclone response. It does not mean the danger has passed, because what happens next could rewrite maps. Narelle had, by March 22nd, been downgraded to a tropical low. In meteorological terms, that means its organized cyclonic circulation had weakened to the point where it no longer met the threshold for tropical cyclone classification. In practical terms, it means the worst named phase of the storm was over. But practical terms don't always capture what a dissipating tropical system leaves behind, or what it can still become. AccuWeather, cited by USA Today in its coverage of the event, had flagged the possibility of a third landfall. The system's westward track across the top end pointed toward the Kimberley coast of Western Australia, a region with its own history of cyclone vulnerability, its own exposed communities, and its own infrastructure challenged by remoteness. Australian meteorological broadcasts documented Narelle's movement toward the northwest coast with the phrasing that emergency managers dread: potential redevelopment. That word, redevelopment, carries weight. It means that a system once thought finished might organize again over warm coastal or offshore water. It means that communities that had stood down from maximum alert might need to return to it. It means that meteorologists monitoring the system's remnant circulation cannot yet issue an all clear. The Bureau of Meteorology continued tracking the system's movement across the top end as of March 22nd. Severe weather warnings remained active. The rainfall that Narelle had deposited across its track, hundreds of millimeters across Cape York, more than 200 millimeters over parts of the Northern Territory, was still moving through river systems, still building toward flood peaks and catchments that were already saturated before the storm arrived. Rivers swell slowly. Flood crests sometimes take days to arrive at downstream communities. The people of Catherine, of communities along swollen waterways in far north Queensland, were still waiting on March 22nd to learn whether the water would stay or rise. That is a particular kind of dread, not the sudden violence of a storm making landfall, but the slow-motion suspense of watching a gauge climb. Expert opinion on Narelle's potential redevelopment remained divided as of the research timestamp. Some models projected continued weakening as the system moved over land and encountered less favorable atmospheric conditions. Others flagged the warm coastal waters off Western Australia's northwest coast as sufficient to support reorganization if Narelle's remnant circulation reached them with enough structure intact. The forecast spread on that question was not narrow. In cyclone tracking, disagreement between models is not a comfort. It is a warning that the atmosphere has not yet decided what it will do, and that the humans living in the possible path have to prepare for the worst version of every scenario simultaneously. The Australian cyclone season officially runs from November through April. March 22nd sits near its tail end, the point when many residents across the top end and the Kimberley begin to believe the worst is behind them for another year. Narelle arrived to correct that assumption with extraordinary force. What no one can tell you with certainty, not the Bureau of Meteorology, not AccuWeather, not the Joint Typhoon Warning Center, is whether Narelle is truly finished. Tropical systems have surprised forecasters in this part of the world before. The Gulf of Carpentaria has nursed weakened circulations back to tropical cyclone intensity in time frames that seemed impossibly short. The warm waters off the Kimberley coast have done the same. Narelle's remnant low was still being tracked, still being modeled, still being watched by every meteorological agency with operational interest in northern Australia. The 500 residents of Numbulwar who were airlifted to Darwin were, as of March 22nd, still displaced. The communities of Cowan, Orukun, and Lockhart River were still assessing damage, still waiting for roads to reopen, for power to return, for the water to recede, enough to understand what had been lost. The rivers of far north Queensland were still running high, still threatening flood peaks that hadn't arrived. No deaths had been confirmed as of the reporting timestamp, but the operational phase, the search, the rescue, the assessment of structural damage across remote areas with limited access, had not concluded. Emergency services were still moving through affected communities. The full picture of what Narelle had done to the physical and human landscape of northern Australia was still being assembled, one road-accessible community at a time. What Narelle demonstrated in its track from Category 3 to Category 5 and across 2 separate landfalls in less than a week is something that Australian meteorologists have long warned about. The capacity of a single system to strike multiple coastlines, each time delivering a fresh assault to communities that may have believed the worst had passed. The Cape York Peninsula bore the Category 4 landfall. The Eastern Northern Territory bore the Category 3 landfall. If the system redevelops, a third coastline may yet bear what remains. And behind all of that is a question that doesn't get resolved in a weather bulletin or a damage report or an official press conference. In a warming ocean with sea surface temperatures consistently above historical averages across the Australian cyclone basin, how many more Narelles are coming? How many more systems will find optimal conditions for rapid intensification and optimal tracks for multiple landfalls? The Bureau of Meteorology's records are long. They document decades of cyclone seasons, each with their own catastrophes and near misses. They also document a trend that researchers return to with increasing urgency. The most intense systems are intensifying faster, and the warm water that fuels them is not retreating. Narelle formed and dissipated as a tropical cyclone in approximately 5 days. It crossed 2 Australian coastlines. It evacuated an entire community by air. It deposited enough rainfall across far north Queensland to keep rivers running high for weeks. And somewhere over the top end, its remnant circulation was still moving west. The storm's name will be retired. The Bureau of Meteorology retires the names of significant cyclones, removing them from the rotation so that future systems carry names without the weight of past destruction. Narelle's name was used once before, in 2013, and survived. Whether it survives 2026 depends on decisions being made right now by meteorological committees who look at damage assessments, displacement numbers, and infrastructure reports and ask a simple question. Was this significant enough to remember permanently? The answer for the 500 people airlifted from Numbulwar, for the communities of Cape York Peninsula still without power and road access, for the emergency managers watching river gauges inch upward in the days following landfall, is not in doubt. The storm is quieter now. The warnings have been partially lifted. The satellite images show a ragged, disorganized remnant where once there was a perfectly symmetrical Category 5 eye wall. But the water is still rising, and the next system is already forming somewhere out in the warm Pacific, waiting for its conditions to align. The Earth doesn't stop between disasters, it simply prepares for the next one.